Unit 10, Lesson 6, Question 4. A 25-foot flagpole is casting a shadow of length d. Let theta represent the angle of elevation of the sun. Express theta as a function of d. Alright, so right away the first thing I'm looking for is what is 25 in relation to theta? It's opposite. And what is length d in relation to theta? It's adjacent. So what trig function, which primary trig function, is a ratio using both opposite and adjacent? And that would be tangent. So tangent of theta equals 25 over d. But we're supposed to represent or express theta as a function of d. That means I need to get theta by itself. In a previous question, I showed how we could do this in one of two ways. We could write arctangent on both the left and the right, and then put everything that was previously there. Tangent of theta and 25 over d. And now we have theta by itself. But remember that arctangent is the same as the inverse tangent. So what else could I do? I could also represent it like this. Inverse tan, and now I have theta equals the inverse tangent of 25 over d. Two ways to correctly represent the exact same thing. We're now going to grab our graphing calculator, and I always suggest that we reset it. So second plus 712, making sure again that we are in degrees. And it asks us to graph on the interval from 0 to 200. Now our output value is going to be theta. So this is going to be this angle that we're looking at. And so let's do it from 0 to, let's go from 0 to 90 to see what that looks like. Okay, when we plug this in, I'm going to plug it in using inverse tangent in parentheses 25 divided by d. We don't have a d, so we'll put an x in, and I'm going to graph it. And now you'll graph what we see here in the box provided to you of part B of number 4. We're going to find that angle of elevation when x is equal to 120 feet, and it actually should be when d is equal to 120 feet. That's what they meant, when d is equal to 120 feet. So when this distance is 120 feet, we want to know what is this angle. The second trace value, let's type in 120, that's my input, and we can see the angle is approximately 11.768, or if we round it to the nearest tenth, 11.8 degrees. Okay, now we have a very small distance, which means the sun has moved much closer. Our angle of elevation is going to be much higher. So now we have a distance on the ground of only 10 for the distance of the shadow, so d equals 10, and our angle of elevation is 68.198 or 68.2, depending on how you round it.